Okay, I think we are live. We'll just give it 1 minute and we will get started. What's up, everyone? Let us know where you're tuning in from today. What country? I'm from Australia. It's early in the morning here. And Frank, where are you from?
I'm in China, and today is still in the Spring Festival. And nice to meet you all.
Awesome, awesome. Paris, France, nice one. California, awesome. Must be early in California. Yeah. Okay, that's enough waiting. Let's get started. Let me just share my screen here. Give me 1 minute to remember where the screen sharing button is. Share screen. There we go. Cool. Okay. Welcome everyone to the Making Private Transactions with Confidential Compute workshop as part of the Convergence Hackathon that's currently running right now. So you should be able to see here the Hackathon landing page. So this workshop is all about privacy. So as you can see, we have a privacy track that we added where we're giving away some prizes to the projects that are built that really focus on privacy and privacy preserving, privacy focused use cases. And this one specifically is about private transactions. So we'll talk about what that means in a minute. But first, I just want to share with you guys, in case you weren't aware, Chainlink Confidential Compute was announced in New York last year in November during SmartCon, unlocking private smart contracts. So there is a blog post here. I'm going to put it in the chat for all of you. There we go. So announced at SmartCon, currently being built, but we have a very early version, a very early access version with some functionality for you, the developers, to play around with today just for this hackathon. So we're very excited for that. So what does this enable for you? What can you actually do with it as you start to think about your project, as you're building out your project? The one specific piece of functionality that is being enabled for you in this hackathon is private transactions here. So if you read this private tokens section, you see they talk about how financial institutions require privacy over things such as token balances, transaction amounts, etc. So what this enables is private tokens or on-chain assets where sensitive transaction information remains private while still maintaining full auditability and regulatory controls. So this makes it possible for you to tokenize and settle a broader range of financial instruments, et cetera, et cetera. You can read that in your own time. But basically it means this simplifies the design of private tokens, supporting confidentiality of balances on-chain and transaction amounts, as well as privacy of both sender and receiver addresses. Okay, no worries. Happy to share that. Now, I think of Chainlink Confidential Compute, as 2 or 3 different things, or essentially 2 different things. So there's the actual private compute aspect of Chainlink Confidential Compute, where you do actual compute in a privacy preserving manner, right? And that's still being built out. But then there's this other side, which is the private transactions part, which we're making a version available for the hackathon here. But what does private transaction means? Well, what does it mean, sorry? And to answer this question and to show you, we're going to use our compliant-focused private token demo sandbox that we have made available just for the hackathon. And this thing is live for you to play around with today. So I'm going to put it in the chat here for you. So essentially, private transactions are a private, you can think of it as a private value movement layer that sits between a token and your application logic, right? Or sort of like a private ledger that sits behind a public entry point and exit contract. Now, with this example here, with this sandbox, what we've done is we've also incorporated Chainlink ACE, which is automated compliance engine into the sandbox here, because what we are doing is we are essentially making you attach a ACE policy to a token that you want to do private transactions with. So if you're not sure what ACE is, I'll put a link in the chat here. It's live. You can essentially create policies against tokens in this example. Maybe you have some allow lists, maybe you have some specific rules around rate limits, etc. But basically, we're saying that when you want to use a token with your sandbox, you need to attach an ACE policy to that sandbox, right? So this basically ensures that we have a baked-in layer of customizable compliance into this, right? This is very important. So yeah, please read up more on ACE if you need to, but just know for now that this kind of incorporates ACE as well. Now, the sandbox is split into two different sections. I like to think of it as a non-chain section and an off-chain section. Now, the on-chain section is essentially a smart contract that I call a vault contract, essentially, and you can see it here. And what this basically is it's a smart contract that acts as sort of like an entry point and an exit point for private tokens. So a token can either be within the public realm or private realm, and you can have it in the public realm, deposit some tokens into the private realm, and then do some private token movements. And then when you so wish, you can then bring those tokens back into the public realm. And that's kind of how you manage the moving across realms, is through this vault contract here. So that's the on-chain part. The off-chain part is essentially an API that sits in front of a secure enclave that has a bunch of APIs here, and we'll go through that soon. But let's focus on the on-chain part first quickly. If you have any questions, feel free to ask them in the chat, and we'll be happy to answer them as we get to them. So if you take a look at the contract events, maybe I should zoom in a bit here. You'll see a bunch of stuff that's happening here. Essentially, what this basically does is there is a deposit one listed somewhere. There's an example right there. That's an event that's emitted when a user successfully deposits funds into the contract. And when it's detected, the off-chain system will credit that amount to the user's private balance in the secure enclave off-chain. There's a withdrawal somewhere here. There it is. The withdrawal is emitted when a withdrawal is successfully processed on-chain. And there's a token registered and a registered token events as well. Maybe there's some here, I'm not sure. But when you see those, essentially they're emitted when a new token is allowed for use in the privacy pool. And the register one is when you register an ERC20 token and you assign a Chainlink ACE policy engine to it. That's when that one is emitted. All right, let's have a quick look at the functions here. I'm going to scroll up and go to here. So you can see there's really two that we want to focus on here. One of them is deposit, and the other one is withdrawal with ticket. So deposit is the entry point for users to move funds into the enclave. It functions as a standard vault, and the user must first approve the token contract to spend the tokens, right? And the withdrawal with ticket, what this thing is, when you've got some tokens in the private token realm and you want to bring them back into your public wallet address, you basically call this function and it executes a withdrawal that's been authorized by the enclave. And you need to actually pass in this thing called a ticket, which is a cryptographic signature that's provided by the off-chain API. And then once this gets validated on chain, then the funds are released and then they sit in your wallet address on the public Ethereum ledger. So that's the on-chain part. Let's take a look at the off-chain. The off-chain part. Going back to the sandbox here. So over here, this is kind of where balances are maintained privately and transfer between users happen privately as well. And there's basically a set of APIs here that are listed. There is some documentation on the APIs as well that you can take a look at your own time. Whoops, I've lost myself there. But essentially, the APIs allow the clients to interact with the secure enclave application, handles authentication, balance queries, private transfers, and all that kind of stuff. And the thing to note here is when you interact with these APIs from your CRE workflow or from your off-chain application, you need to, these APIs use EIP 712 signatures for authentication. So you need to sign all requests accordingly with your wallet address while doing the transaction. And we've got these as APIs, so that obviously you can use these from within a workflow, in CRE or as part of some other application. So just very quickly, the APIs that are here: retrieve balances, self-explanatory. You pass in an address and it will tell you what balances are for what tokens in this kind of a private domain. You can list all the transactions for an address. You can do a private token transfer from address A to address B for a particular token. You can withdraw tokens from this private realm, which will generate that ticket that I was talking about before, that you then use to actually redeem them back on in the Vault contract. And then you can generate what's called a shielded address. So this thing's really interesting. This is where if you don't want your address to be known when receiving tokens, for example, you can generate what's called a shielded address, which is another address. It looks like a normal address, and it basically maps back to your original address so that you can share the shielded one and you can receive tokens into it, etc. And no one will know that it's linked to your original wallet address until you obviously go to redeem those tokens back in the public realm. So these are the APIs. You can call them obviously programmatically in your CRE workflows, but for the purposes of the Sandbox, you can actually also interact with them via the Sandbox UI here. So you can connect your MetaMask wallet. You can modify the data. So this is a private token transfer. You can specify a recipient, token, amount, and you can actually sign and call the API endpoint from this UI itself as well, which I think for the demo today, we're going to be doing that. Okay, so now that you know what Chainlink Confidential Compute private transactions are, no questions in the chat. Yeah, cool. What can you do with them, and how can this, Sandbox be used? So if you take a look at the Hackathon track specifically, we do list some example use cases that we think would be really useful for something like this, such as sealed bid auctions and private payments, private treasury and fund operations, private governance payouts and incentives, private rewards and revenue, and then over-the-counter and brokered settlements, maybe some dark pool stuff as well. But really, it's up to you. We're very interested to see what things you think would be great for this kind of technology. So what we've done here now is, Frank here has put together an awesome demo, which I will share here in the chat. There we go. And what he's going to do now is he's going to walk everyone through this demo. And what the demo basically does is it's going to show you how you can actually use this Sandbox that is here, how you can do some private transactions using it, and you kind of see the end-to-end flow. Essentially what that flow is, we're going to first create a token, deploy it onto Sepolia, mint some tokens, to ourselves. We are then going to deposit some of those tokens into the Vault contract that I shared with you here. Right, we're going to deposit some tokens into that private realm. We are then going to transfer some of those tokens to another address, probably a shielded address for a second account. And then we're going to see that everything is just within the private realm and nothing is visible on chain. And then the last step will be to then withdraw those tokens from that second account back into the public realm, and then we see them in the second account on Etherscan as normal token balance there. So yeah, I think that's it for now from myself. But yeah, Frank, did you want to introduce yourself before you start getting into the demo? And then, yeah, you can go straight into it.
Yes, thank you, Harry. And hey, everyone, this is Frank. And nice to meet you all, to all the developers all over the world. And welcome to this workshop. And just as Harry mentioned before, I'm going to give you a quick demo to show how to use the confidential computing with a smart contract. Actually, we deployed a contract called a vote. And if you want to transfer a token to another address, but the owner of the recipient address does not want to expose their address to the public, this one can just generate a shielded address as discussed before by Harry, and you can send the token to this shielded address, and this person can just retrieve or withdraw this token from this vote by just using their shielded address. And during these transfers, no one knows who is the recipient of this token. But in order to make sure that everything is under the compliance, we just use a ACE with our token. So in the first step, we need to just register a token and a policy from the ACE in the vote smart contract, so that people will know, yeah, this token is supported by the vote smart contract powered by the Chainlink Confidential Computing, and also based on the policy, this token can be transferred. It is not a super crazy thing. We set a compliance. We use ACE to set a compliance and rules for this token transfers. So let's start, and let me just share my screen. Share my screen, the whole screen. Okay, let me first go to the web page of that. First go to the web page of that private token transfer demo, and in this web page, in this GitHub repo, I write everything in several steps. And if you cannot come with me in this demo, you do not have your laptop with you, you can just go through all the steps I did today in your own laptop by following the README of this repo. So in this repo, first thing I want to introduce is the architecture of the on-chain section and off-chain section discussed by Harry. So for the on-chain section, we have several different contracts. The most important one is the vote contract. This contract is powered by the Chainlink Confidential Computing. And if you want to make any confidential transfer for some tokens, you need to first register your token and also a policy in this vote smart contract. Then you can just transfer this token, and the token can be transferred to a shielded address owned by some recipient. And the recipient can withdraw a token with a ticket, and I will show how to do that later. But for now, you only need to understand is the on-chain section. We have two smart contracts. The first one is a vote contract, and the second one is a ERC20 token smart contract. That is a super easy smart contract inheriting the ERC20 smart contract. And the third one is a policy engine, and that is the smart contract like a guard smart contract to just rule under which circumstances or under which scenario this token can be transferred illegally. This token can be transferred, and except for the on-chain section, the off-chain section is just a off-chain service provided by Chainlink, and all the events emitted from the on-chain smart contract will be tracked by the off-chain service, and we will have a database and have the computational computing running off-chain. And when we get the architecture, let me go to the first part of the Foundry script. So because in the first step, we need to register the token and a policy with this token into the vote smart contract. So there are some smart contract interaction. So one way you can do this is go to the Etherscan. In the Etherscan, and you can find that vote smart contract, because the contract has been verified by Chainlink. So you can go to this contract tab to read all the codes, and also you can click this one, the write smart contract. So what you need to do is to register with two things. First one is a token address, and the second one is a policy engine, the rules to just define how this token can be transferred. But it's a kind of the time consuming. So I created some script to do this. So in the repo, we have some scripts in the folder source, and in the source folder, I'm sorry, not in the source folder. Source folder is used to save the ERC20 smart contract. They are in the script folder. So in the script folder, we have quite a lot of different scripts. The first one is to deploy. Let me zoom in so everybody can see that. So first, the script is to deploy a ERC20 token. It's super easy. It's just like a empty one with only not this one. It's oh, I'm sorry, not in this folder. In the source folder, the ERC20 smart contract is super easy, and it's just a smart contract, and it inherits the ERC20 and the ERC20 permit and ownable, and that's it. It's just to use all the default functions defined by the ERC20 tokens from the OpenZapling library. And in order to deploy that, I write some scripts under this folder. So the first one is to deploy this ERC20 tokens. The second one is to deploy a policy engine. If you have never heard about the ACE, I talked as before, it is just a policy, and you can understand it as some kind of the more advanced ownable contract. It will have some guard to just protect some functions in the smart contract. For example, in the ERC20, you want to set that some recipient cannot be used to receive this token. You can set this rule into the policy engine. But for this demo, for simplicity, we just use a empty policy engine for the token we deployed before. So the second script is to deploy a empty policy engine, so everything can work with this policy. And if you want to have some customized rules, you can also set it in this script. And the third script is to mint this token we deployed in the first step. And then we approve this vote smart contract can use our token minted to our address. And the final thing is to register and deposit this token into the vote. And all this script from the 01 to the 06 can be done with one script called setup all. So you have two options. So the first option is to run the 01, 02, 03, 04, 05, and 06 to register a token to the vote and start using this token to do the private transfer. And option B is to run this script. This script will do everything the scripts from the number 1 to number 6 to do. Okay, let me just use this setup all script to just set up everything. So I have already cloned this repo into my laptop. Let me go to the terminal, this one. Okay, so I'm here in this private transaction folder, and this is all the files we can see in this GitHub repo. So what I'm going to do is to follow the README. Follow the README, this one. Well, by the way, if it is the first time for you to use this repo, you just make sure you install all the dependencies using the forge install, and you also need to build the script and a smart contract with this command forge build, and a -- while iron is just used to optimize the compiler process. And you also need to export the private key and the RPC URL, because we need to interact the smart contract on the Ethereum Sepolia network. So you need a private key, and you need to have some Sepolia ETH as a balance in your account, and you also need to give it a RPC URL. You can get a free one from the Infura or Alchemy, and once you get your RPC URL, you export that into your environment variables in your terminal. And I have already done that, so I'm not going to do that in this demo. But if you want to do that, if you want to go through the demo, you need to export these two environment variables. So I'm just run this command to all-in-one setup. Let me go to the terminal and hit enter.
Hey Frank, while that's running, there's a great question in the chat. Do you know this one? Can I ask why you're implementing ERC20 permit in your deploy contract?
Yeah, for the ERC20 smart contract, you need to have some mechanism for the other smart contract to create some permissions for the for some data, and that is necessary for the ERC20 token to implement this smart contract.
Cool, thank you.
And this all the smart contract are deployed and all the interactions are done, as we can see in the log here. So this is the setup complete. And let me zoom in a little bit. And for this one, the simple token is deployed in this address, and this is a policy engine proxy, and this is a policy engine implementation, because we use a proxy to call to the dedicated call the policy engine implementation. So we have two smart contract, and this is a vote smart contract, and there are 100 token minted to my address, and there are 10 tokens deposited into the vote smart contract. And let me go to the Etherscan to just make sure everything is correct. Let me copy my address from the MetaMask. My address. It's a little bit slow. Okay. Yeah, as you can see here, it's all 1 minute ago, these transactions. So first, we created several different smart contracts. As you can see, we have the ERC20 token smart contract and policy engine proxy and a policy engine implementation. And then we just mint like 100 token from the ERC20 smart contract and approve this token can be consumed by the vote smart contract. And then we register our token with the policy proxy in the vote smart contract, and then deposit into the smart contract. And that is what we are doing with that script we're running in our terminal in this one. Okay, so when this is done, we have already set up everything we need for the vote. And let me just go to the second part, using the private transactions. So before we're doing that, we need to know that we will use the two EOA, the external owned account on the EVM. The first one is a sender, and the second one is used as a receiver. The sender is just the address we use to set up all the configurations for the vote smart contract, and the receiver is just another account of mine, and I use that as the second account to receive the private transfer from the first account. So what I need to do is I need to first check the balance of the account one to see how many tokens is in the balance. And let me go to this one, the compliance focused private token demo, and this is option part. And here there is a tab called retrieve balances, and let me click that. And before you're doing that, just to make sure the account address here, the connected one, is the one you want to use with the private transaction. And for now, because I'm using this one, the smart contract address is let me call it that. is from the C5D1. So it's the C5D1. So just pay attention to this, because if you use the wrong address here, that something bad will happen. The response will not be successful. So I connected the correct the account address here, and here the payload will be generated automatically from this front end. And what you need to do is just sign with MetaMask and confirm. And there are going to be a payload with auth. Actually, that is a signature, and it's generated from the front end, and you can submit this request to the backend. As you can see here, I have quite a lot of different tokens because I tested before this demo. So for now, let's see our token address just deployed. Go back here, and our token address is this one. It's 3406 at the start and 9E84 at the end. So let me check this. So 3C4. Oh, not this one. Why that is different? Oh, maybe I'm using the last one. I'm sorry. So for this one, yeah, this one.
It's the bottom one, isn't it?
Yeah. I'm using my last command result. I'm sorry for that. So, well, I hate these zooming things. Yeah, this guy is ended as a 08D and a 08D. So for this token address, I have actually I have 10 tokens because the unit is weight, so it's 1 power 10 19. There should be 19 zeros after this one. So I have 10 tokens as a balance here in this account. So first thing, I deposit my token into this vault and I check the balance. I really have this balance in this vault. So second thing I'm going to do is step 8 to switch to the account 2 and verify this address on the front end. And then I'm going to check the balance of the account 2. So let me go back to the front end. And you know how to just switch the account with the MetaMask. Just click this MetaMask and switch to another one. And you will see this new address will be shown here. If it does not work, just go to the dApp control by clicking this icon and click that the dApp management and edit that to just check all the addresses you want to use to connect to this front end, to this dApp. And if you check every account, you can just switch the account in the MetaMask or any other extension wallet, and this address will be connected to this website. Okay, let me just switch to my second account and let me refresh the page. And if I use the second account, I can still check my balance, sign with the MetaMask, and confirm, and submit this request. And as you can see here, the token is not here. This is the old token I used for test. The token we just deployed is not displayed here. That means the second account has no balance of that token we just deployed. Okay, cool. And this is step 8 and step 9. These two steps are just to check the balance of the account 2 to see if the token we just minted is in this account or not. We can see that there is zero tokens of in the account 2. And next, I'm going to just generate a shielded address for account 2. And this shielded address, as I write here, it looks like a no more Ethereum address that is no more EOA, but it cannot be linked to the account 2's real address. So when you generate a shielded address, no one knows that a shielded address is just generated by you, and your account cannot be linked to this shielded address. So let me do that. Go back to the front end and click this home button, and there is a tab called generated shielded address, and I'm using my second account. And just as before, the payload is generated by front end. There is nothing need to be changed because this account is already automatically filled here. And let me just sign with my MetaMask and confirm and submit a request. Now you can see that API response only have one element in this JSON file, the address. And this address is the shielded address we just generated from the account 2. And let me create another tab because I need to keep this address. I'm going to use that. I'm going to use that in the next step. Let me create a new address, and next, what I'm going to do is to switch back to the account 1 and to just do the private transfer. And let me go to this one. First, let me copy this address. Go to this one and click this tab, the private token transfer. That's the most important step I'm going to do this tonight. And switch back to the account 1. This one. And as you can see, the address is switched back to the old one and with the C5D1. And if I want to do the token transfer, there is at least the two things I need to fill in this payload. The first one is a recipient to whom I'm going to transfer this token to. And let me paste the shielded address. That is 09661. Let me just check if they match. Oh, that is lost. Fine, it's fine because I copied that into my clipboard in advance. And the token address, I can get it from my terminal. It should be this one. So I pasted it here. So for now, the message is I'm going to transfer this token from my account number 1 to the account number 2. But actually, this address is not the original account number 2 address. It is a shielded address generated from the account number 2. And let me sign with my MetaMask, confirm, and submit a request. Yeah. The API response is 200, which means that this request is successful, and we have a transaction ID. And actually, you don't need to care about this transaction ID because it is used in the off-chain service. We don't need to use that on the on-chain smart contract. And this just tells us the transfer, this private transfer is successful. And let me just go back to the balance. Go back to the balance here, retrieve balance, and switch to the account number 2 to see if the balance is updated. Sign with MetaMask, confirm, and submit request. Yeah, as you can see here, so in the first time we check the balance of the account number 2, there is only one token listed here. That is the old token I used for the test before. And for now, we can see here is a new token. It's end with a B08D, and that is exactly this token we just deployed in the first step. So this token is the account number. In account number 2, we have some balance of this token, and this is one token actually. It's 18 zeros after 1. So
just quickly, Frank, and this is in the in the privacy realm here. If we take a look at that account in the off-chain, in the on-chain account, what do we expect to see? Do we expect to see anything yet, or is it going to still show nothing?
It will show nothing because this transfer happens in the vote smart contract, and the state of the balance will only be known by the off-chain service of the Chainlink, that confidential computing running in the enclave. If you just see your account on the Etherscan, if I go to the Etherscan, you will see nothing. Let me copy that. The address is here, copy that, and check it on the Etherscan. So the last transaction is 3 hours ago, which means there is no one can see this token is transferred to the account number 1, account number 2. Yep. So that is why we call that the private transfer.
Thank you.
So next, you may wondering how can I just withdraw this token to my real account, which is very easy by using the API call. And there is a tab called withdraw tokens. And click this tab. And for now, you can see that I'm using the account number 2, ends with D7B2, just this one, D7B2. And let me just withdraw the tokens. With this one, the only thing you need to fill in this payload is the token address. Let me get this token address here. This one. And this is the amount we want to withdraw. It's a 1 token in V unit. It means that we have 18 zeros after 1. And sign with MetaMask. Confirm that, submit request. Well, the response is successful, and we have an ID, account, and a token address, amount, and this is just for your information. And the most important part is this one, the ticket, because you need to just submit this ticket to the Chainlink vote to the vote smart contract, and the Chainlink will just check this ticket to see if the withdrawal transaction is valid or not. And if you do not have this ticket, you just go to withdraw this token from the vote, the transaction will fail. And that will promise and ensure the correct person withdraws a correct token with a correct ticket to protect the token cannot be withdrawn by anyone else. And let me just copy the ticket and go to the vote smart contract, this one, in the vote smart contract. Because the smart contract is verified by us before, so you can just use the Etherscan to call functions of this smart contract. And this is the register. What we want to do is withdraw with ticket. And let me just paste the ticket here. And the amount should be this one, the amount, copy that, and paste it here. And a token address, we can also get it here. This is token address, and paste it here. And oh, I forgot to connect my wallet. Let me check if I'm on the right. Oh, in this account. Let me connect. Yeah. Oh, I'm sorry, not this account. This is account number 1. And I need to use this account. And this is not refreshed automatically, so I need to refresh manually, which means I lose everything I input before. And I'm sorry for that. So first connect to the account number 2 and copy the oh my god, that is lost because I switched the account in my MetaMask. So the page, these 2 pages are automatically refreshed. So I lost the response in this page. Let me see if I copied that before. Ticket. Oh no, I lost my ticket. But anyway, Let me see if I can create another ticket with account number 2.
Can you withdraw another amount, like a smaller amount, if you have some left?
I don't know, because I withdraw the whole balance I have under this account. Let me see if I can create another ticket. Maybe not. I never tried it before. Maybe not. This is a token amount, token address here, and sign with MetaMask, and submit request. Yeah, that means the insufficient balance, because because I only have one token under this account number 2. I only transferred one token to this shielded address. So if I have already created a ticket, but I lost that ticket, that means I cannot create another, because that ticket will allow the user to withdraw a token from this balance. If I have 2 tickets, which means that the either ticket of these 2 tickets will be invalid. So maybe I need to do
just quickly, Frank. I think if you go into the list of transactions API, you might be able to see the ticket for the account.
Okay. Let me.
Let's try that first.
Number 2. Submit that. Oh, quite a lot of transactions. It should be this one, the token. Yeah, you're right, Harry. We have the ticket here. Thank you for that. Yeah, let me copy the ticket from the history and go to the Etherscan here and paste the ticket here, and
There's a great comment from William here too. You can use Tenderly for testnets and add unlimited funds as well. So if you ever run into this, you can just easily have more.
You mean you use the Tenderly to find this ticket?
No. I meant instead of using the way that we're doing it here. Sorry, I didn't mean to confuse you. You can keep going.
Okay. And yeah, amount is 1 Ether, and let me go to the token address, this one. And when you input these 3 parameters and click right, the MetaMask should pop up, and click confirm. By doing this, we just call the withdraw with ticket function in the Vault smart contract to just withdraw 1 Ether of the token we deployed in the first step to the account number 2. And this token is transferred from the account number 1 to the shielded address generated from the account number 2. And we can directly use our account number 2 to withdraw this token. And no one will know that this token is transferred to the token number 2 before we withdraw, or even you just withdraw like a 100 way or 200 way, that the amount you withdraw is different from the balance of the account number 2, and there is nothing can be linked these 2 addresses together. And let me go back to my second account and check if I have that token. The latest transaction is this one. It's happened 52 seconds before, so that is just a transaction I sent to the Vault smart contract. Let me click that one, and you can see this one. From this address to this address. This address is the Vault smart contract address, and this is my account number 2. And you can see from the Vault smart contract, 1 Ether of this demo token is transferred to the account number 2. And that is the whole demo I want to show tonight. I'm sorry, today, maybe. And the thing is that you can use the Chainlink confidential computing to generate a shielded address and transfer this token, some specific token to this shielded address, and use the original account to withdraw this token from the vault to just implement the private token transfer. And if you go to this repo, we also provide a folder called API scripts. And as you can see in the demo, I use this UI, like click this button, click that button, and to input everything manually. And if you want to integrate this one into your dApp, you cannot require the end user to use the tool like this. So we create some TypeScript script to just send all the APIs I showed in this demo. For example, in the balances.ts, you can use npx script balances.ts to just compose the payload and send the payload to the API, and you will get the same result as I show in the UI. And for example, you can see the balances, private transfers, shielded address to generate a shielded address, and also the transactions to check the history of all the transactions under a specific account. And you can also do the withdrawal to generate a ticket. And also by doing this, you can use the UI to call the functions. And we also create a script called withdrawal to use the Foundry script to call this function in the Vault smart contract. And this will be also helpful if you want to do this in the programmable way. So, and everything I talked today is can be found in the README, and you can just follow steps I write in this README and to achieve everything I achieved tonight. And yeah, I think that is pretty much I want to show for the demo today. Harry. And you are mute, Harry.
Yeah, thank you, Frank. Thank you so much. Let me just share my screen again. Just to quickly reiterate, when you're building CRE workflows and you want to maybe do some private transactions as part of your workflows, as Frank said, he's got a bunch of scripts that he has in the API scripts folder. You can use these as kind of a means to incorporate into your workflows. Obviously, you need to use the CRE HTTP GET capability to do the API calls, etc. But this should definitely help you get going there. Okay. I think there is a question in the chat. Let's take a look here. Sorry, I want to make sure I understand correctly. I don't understand which part of the stack is giving us the privacy here. Is it the Vault contract? Is it your web demo app? So the privacy aspect here is that using the Vault contract as well as the off-chain service, you are able to do private transactions or private token movements as part of your CRE workflow. So that's essentially what the privacy aspect is the ability to move value or tokens or whatever the tokens represent around, not on the public ledger until you want to actually display it or bring it back to the public ledger there. So hopefully that answers that one there. I did put the repo in the chat if you don't have it, so please take a look. You should find it a couple comments from the bottom there. Okay, thank you again, Frank, for that demo. So as you see, Chainlink Confidential Compute and private transactions here are a very powerful way to enable privacy-preserving, compliant movement of value as part of your hackathon project. And I really encourage everyone to think about how you can leverage this technology in your project submission. How can you bring some form of private value or private token movement what kind of ACE policy could you apply to this token as well? I encourage you to have a think about it. We're very interested to see what kind of use cases developers come up with when they combine this together with CRE workflows. I'm especially interested in seeing this, and this is a very interested in seeing the use cases that this enables as well. And remember, you can apply to multiple tracks too. So if you're building some kind of DeFi application that has some private token movements, your project can be submitted to the DeFi and tokenization track as well as the privacy track, right? You can, as long as it makes sense, you can apply to both, and you can submit to both. So if you need support, please reach out to us in Discord. We have some office hours as well. Am I sharing my screen? I am. If you take a look at the schedule here, we have some office hours, I believe today, actually. What's today? 19th. 20th. Yeah, we have some office hours coming up where you can just join, you can ask questions, you can share your project, you can share your idea, you can get feedback or validation on your use case, and we're happy to sit with you there as well. So for help and support, Discord and the office hours are definitely the two best places to get support. I'm going to share some links again, just in case you didn't grab them before, in the chat. So there is the Sandbox itself and more info on Chainlink Confidential Compute is there. Cool. Okay. Thank you everyone for joining. Hope you have a great rest of your hackathon. Please ask any questions that you still have in the Discord for now, and we'll continue the conversation there. And best of luck with your hackathon submissions. Thank you all, and thank you, Frank, for joining the live stream as well and giving us this demo.
Thank you, everyone. Thank you.
Thanks all. Bye.
Bye.